So, yung topic natin i-cover for today is yung ating fundamentals of fluid flow. So, yung mga discharges, mass flow rate, weight flow rate, and etc. So, this is our PowerPoint. So, recap lang natin yung ating fluid flow na mga topics. Okay, next slide. So first is we have the flow rate, yung ating Q, or discharge, or yung mga volume flux. Yung other terms para sa ating discharges. So isa pa, volumetric flow rate. So isa lang yan sila. Marami lang pangalan. So ito, it falls down sa lahat ng marami kasing terms, pero isa lang yung kayang meaning yung ating discharge. So discharge represented as capital letter Q. So ang kanyang definition, it is the amount of fluid passing through a section per unit of time. So we have the formula para sa ating flow rate, yung ating discharge Q na equals to V times yung ating A, yung big letter A. So ang kanilang mga representation or ang kanilang meaning, yung ating Q, yung ating volumetric flow rate or yung ating discharge. Yung ating V is ang ating velocity, yung flow velocity. And then yung capital letter A is the cross-sectional vector area or yung ating cross-sectional area ng ating pipe or yung vessel ng ating liquid. So next is ang ating mass flow rate, which is represented as the big or yung ating capital letter M. Its definition or yung ating relationship between the discharge and the mass flow rate and the same to the weight flow rate is that yung ating mass flow rate is raw or yung ating density times dun sa ating discharge or yung ating volume flow rate. So ito ang kanyang relationship sa ating discharge Q. And it's the same sa ating volume, ating weight flow rate. So for the mass, ang ating times ating discharge is yung kanyang density. And for the weight, ito times natin sa ating discharge is yung ating unit weight. So wala na tayong slide for our weight flow rate. So ilalagay natin dito ang formula ng ating weight flow rate. So ang ating weight flow rate is represented as big letter W. So it's equal to the unit weight ng ating fluid times ng ating so yan ang kanyang formula. Next slide is regarding sa ating energy and head. So the energy possessed by a flowing fluid consists of a kinetic and the potential energy. And then yung ating potential energy is subdivided or it has two types, which is yung ating elevation or gravitational energy, and next is yung ating pressure energy. So what is the kinetic energy? Kinetic energy is the energy that the objects possess due to their motion. So ating formula para sa kinetic energy is equals to 1/2 mv squared. Okay? So yung ating m is mass in terms of, or ang kanyang unit is kilogram. And then yung ating velocity, ang kanyang unit is meter per second. So ang ating kinetic energy, ang kanyang unit is naka-joules or pwede ding K, diretso lang natin, K-M per second or meter per second or simplified as joule. Next is yung ating potential energy. So meron tayo ditong representation. Itong part na to. So wait lang, i-erase lang natin para malinis yung ating PowerPoint. So here, pag toss up natin dun sa ating ball, and then at some point to the highest elevation or yung sa pinaka-top, yung peak part na naabot ng ating ball, at some point, millisecond, magsa-stop yung ball na yon before siya magpo-fall down. So at that point, yung ating kinetic energy is equals to 0. Pero yung ating potential energy is merong value, which is equals to mass times gravity times height. So ito yung ating potential energy. So once maabot nyo na yung point na yon, mag-fall down, start na mag-fall yung ating ball. So with that motion, meron na tayong kinetic energy. And then since nag-move na yung ating object, yung ating potential energy is equals to 0. So again, ang ating kinetic energy is equals to 1/2 times mass times velocity squared. So yung ating by conservation of energy, yung energy before is equals to the energy after. So yung energy before, it refers to the potential energy. So yung ating potential energy is equals to the kinetic energy. So at the beginning, the energy is all potential. So kung ibig sabihin nun, at rest kasi at the beginning yung ating object. So without any force exerted on the object, naka-at-rest yung ating object. So even it is in at rest state, it has a energy. It possesses an energy. So yung energy na yon, it is referred as the potential energy. So here, sa potential energy and kinetic energy, we have same element, which is yung ating mass. So yung ating mass on both sides tells you that the final velocity doesn't depend upon the mass. So last is yung ating kinetic energy. So the final energy is all kinetic energy. Okay. So the velocity just before the impact, yung ating V before the impact is equals to square root of 2gh. So square root of 2 times gravity times yung ating height. Ito yung ating height from the highest point of the object na na-reach niya. Okay. Next. So next is yung ating total flow energy, which is represented as capital letter E. Okay. So it is defined as the total energy or head in a fluid flow. So yung ating energy, total energy, or yung E, or head, kasi yung energy na to, in terms, yung unit niya is in terms on distance. So minsan, yung ating standard na ginagamit is naka-meter. So pwede pa rin yun siya mag-change. Naka-feet man tayo, depende sa unit na ginagamit natin. Pero ito, ang kanyang unit is in terms sa distance or yung ating naka-meter siya. Distance, range, basta naka-meter yung ating unit. Pag ito yung ating ginapag-usapan. So yung total energy or yung head natin in a flow, yan yung ating total flow energy. It is the sum of the kinetic and the potential energies. So here we have standard equation para sa ating total flow energy. So wait lang, erase muna natin yung mga nasa slide natin. Excuse me, naglalaro yung pusa ko. Ang ingay-ingay nila. So, proceed tayo. So, ito nga ang dedication para sa total flow energy. So, if we have given na pressure dun sa ating problem, so we will incorporate that in our formula. So, meron tayong energy, meron tayong P sub 1. And the next, stop natin na yun nga, natin of some so we have P and S. So here, yung ating mass is represented density, di ba? So, yung ating kinetic energy is 1/2, nothing siya. Pero, times yung ating velocity sa 1 plus pero yung ating RTP sa gravity times yung ating elevation head o yung ating equals to constant. Next is yung ating power. So yung power natin formula is equals to the discharge energy here and then unit weight. So then ang ating equation or formula power is naka 1. Okay. So, minsan, sa problem natin, HP ang binabigay. So, 1 HP is equals to 746 watts. So, i-convert yan natin given. If ever na watts, naka-HP ang units sa ating problem. Okay, next. So, we have here the fundamental equations. Equations of fluid dynamics. Okay. So first we have the law of conservation of matter or mass. Same lang yan sila. Okay. So with this law, it stipulates that the matter can be neither created nor destroyed. Through it, though it may be transformed, example, by chemical process. Since this study of the mechanics of fluids excludes chemical activity from consideration, the law reduces to the principle of conservation mass. So next, we have the energy, Bernoulli's energy theorem. So with this law, it states that the energy may be neither created nor destroyed. So same lang sila yung ating conservation of matter. So with this, yung ating energy can be transformed from one gas to another. So example is from potential energy, it can be transformed into kinetic energy. But none of those energy is actually lost. So transform mo sila in other, kumbaga, if matter into another object, kumbaga, the energy, matatransform to other form to kinetic. So engineers sometimes loosely refer to these energy losses due to the friction. But in fact, kahit na nag-turn tayo, yung friction na yun, it actually transforms some energy into heat. So none of those energy are really lost. So last, we have the law of conservation of momentum. So with this, it states that the body motion cannot gain or lose momentum unless some external force is applied. The classical statement of this law is Newton's second law of motion. So we have here, force is equals to rate of change of momentum. So, ano lang natin yung ating mga formula. Important equations or formula with regards dun sa ating mga law na topic. So here we have the or math. Matter, as we talked a while ago, it is simply changed into a different form of matter. This principle is known as the conservation of mass, and we use it in the analysis of flowing fluids. The continuity equation is based upon with the principle of conservation of mass. For a fluid flowing through the pipe at all cross-section, the quantity of fluid flowing per second is constant. Or in other words, for a steady and incompressible flow such as water, the rate of flow of liquid remains constant at different section. So even yung ating area here is medyo liit compared to this section na lumaki yung ating diameter. So yung ating inflow with the control volume or yung ating control space surface, yung kanyang outflow is the same or remain constant. Next, and for any control volume, the principle of conservation of mass says that the mass entering is equals to the mass leaving plus increase of mass in the control, yung ating control volume, ay control surface, as we have here, for example. Next, for the steady flow, there is no increase in mass within the control volume. So yung ating mass entering per unit of time is equals to the mass leaving per unit of time. For the incompressible, the density of the fluid is constant throughout the fluid continuum. Yung mass flow natin na M, entering may be calculated by taking the product ng ating times yung ating volume. So we have here row 1, Next, yung ating mass flow is therefore represented by the product of PQ. We have here. Hence, yung ating leaving mass flow rate. But since flow is incompressible, the density is constant. So, yung ating discharge leaving. This is the continuity equation for steady incompressible flow such as water. So we have also one velocity of one, and then equals to or yung ating times area times velocity para to. But since ating law is equal to is equal to density. So mag-equal pala sila. So mag-simplify with this formula. So area 1 velocity equals to the velocity. So the okay, this is 2. So equals to the area times the velocity of 1 and then So if the velocity of flow across the entry to the control volume is measured and that the velocity is constant at V sub 1, then if the cross-sectional area of the stream tube at entry is A sub 1, so yung ating, again, alam niyo naman ito. So yung discharge natin, ang kanyang formula, di ba? Velocity times yung ating cross-section. So if we have entering at section, fluid entering at section 1, so yung ating mga sub representation is magiging 1 lang din. So V sub 1 times A sub 1. Thus, if the velocity of flow leaving the volume is V sub 2, then the area of the stream tube at exit is A sub 2. Okay? Therefore, yung continuity equation may be written as this of topic natin kanina. So the application ng ating continuity equation, we can apply the principle of continuity to pipes with cross sections which change along their length. So we have an example for that. So we have here. So ito, kapag ganito yung ating figure or condition dun sa ating problem, ang gagamitin natin na formula is yung ating continuity equation. A liquid is flowing from left to right. So we have the figure here. And the pipe is narrowing in the same direction. By the continuity principle, the mass flow rate must be the same at each section. So we have section 1 and section 2. The mass going into the pipe is equal to the mass going out of the pipe. So we can write same na. Natapik na natin kanina. So as we are considering a liquid, usually water, which is not very compressible, the density changes very little. So we can say that yung ating density is mag-equate lang. So maka-cancel out. This also says that the volume flow rate is constant or that yung ating discharge at section 1 is equals sa discharge sa ating section 2. So i-elaborate natin yung formula. We have here yung ating continuity equation. So kung kukunin natin ang velocity dun sa exit, ito ang ating i-consider na formula. And if in terms of diameter, yung ating okay, as the area of the circular pipe is a function of the diameter, we can reduce the formula with this. So kung hinahanap natin yung ating velocity sa exit, so equal siya sa d sub 1 squared over d sub 2 squared raised to 2 times sa ating velocity sub 1. So next, by the continuity principle, we can also be used to determine the velocities in pipe coming from a junction. So here we have the sample for figure para sa ating junction. So the total mass flow into the junction is equals to the mass flow out of the junction. So meron tayong section 1 kumbaga, and then 2 and 3. So with that, we have at section 1 is equals to section 2 plus section 3. So rho or density sub 1 times yung discharge sub 1 is equals to the density sa 2 times sa discharge sa section 2 plus again yung ating density dito sa section 3 times sa discharge dito sa section 3. When the flow is incompressible such as water, yung ating mga rho or yung mga density is maka-cancel out. So we will have the discharge sa 1 is equals to sa discharge sa section 2 plus discharge sa section 3. Okay. Next is yung ating work and energy under the principle of conservation of energy. So we have the following conditions. Yung ating friction is negligible or i-neglect natin yung ating friction under this principle. And then yung sum of kinetic energy and gravitational energy is constant. So we can recall yung ating mga formula sa ating kinetic energy is 1/2 times mass times velocity squared. Sa ating potential energy is mass times gravity times ng ating height from the datum. So to apply this, it will to apply this to a falling body, we have an initial velocity of 0 or yung ating kinetic energy is 0 and it falls through a height of h. So from initial, meron tayong kinetic energy na 0 ang value and then yung ating potential energy may value with regards to mass times gravity times ang ating height. Then sa ating final kinetic energy, if by value yung ating kinetic energy, yung potential energy natin is 0. It falls to the condition if we have the falling body, ha? Ito yung condition for these values. So, ang ating kinetic energy, ang value is 1/2 times mass times velocity squared. So, we know that the kinetic energy plus potential energy is constant. Okay? So, yung ating potential energy is equals to kinetic energy or yung ating velocity is equals to square root of 2gh or 2 times gravity times height. Square root of 2 times gravity times height, I mean. So under the principle of conservation of energy, we have here the Bernoulli's energy theorem. So it states that if the fluid experiences no head loss, again, it states that if the fluid experiences no head loss in moving from initial section to the final section, then the total energy must be equal in both sections. So yung ating conservation of energy or yung Bernoulli's equation, we can recall from Euler's equation na dt over density plus velocity dv plus yung ating g dg or dz is equals to 0. So also recall that viscous force were neglected. So yung ating flow is in viscous. Tama ba itong ating, hindi ko maklaro. So if one integrates yung ating Euler's equation along a single streamline between 2 points, yung ating formula, it will arrive sa Bernoulli's equation. So here we have example nito. This is from section 1 and this is section 2. So we have, pag meron tayong pressure dun sa problem, so incorporate natin sa ating equation. So meron tayong P sub 1 times yung ating density plus velocity sub 1 squared over 2 plus yung ating potential energy potential energy na G, yung ating gravity times yung ating Z sub 1 or yung ating datum or yung ating head at that section is equals to dun sa ating section 2. So same lang sila, nag-matter lang kung saan section sila makukuha. So is equals to constant. Again, yung ating Bernoulli's equation we have here. We see that from applying equal pressure or zero velocities, we get the two equations from the section above. They are both just special cases of Bernoulli's equation. So we have some restriction that is applicable, restriction in its applicability sa ating Bernoulli. So we have a flow is steady. Yung ating density is constant, which also means that the fluid is incompressible, such as water. Friction losses are negligible. The equation relates that the state at 2 points along a single streamline, not conditions sa 2 different streamlines. So dapat, condition natin dito is single streamline. So we have limitation and assumptions. So for the limitations sa ating Bernoulli's equation, it is applicable to ideal compressible flow. The heat transfer into or out of fluid should be zero. The temperature remains constant so that internal energy does not change. And then the effect of presence of any mechanical devices between two sections is ignored. And we assume that yung ating viscous effects are assumed negligible. We assume that the flow should be steady and then incompressible. And then the equation is applicable along a single streamline. So yung application of Bernoulli's equation can be applied to a great many situation, not just the pipe flow we have been considering up to now. In the following section, we will see some examples of its application to flow measurement from tanks, within pipes, as well as in open channels. We acknowledge practical uses of the Bernoulli and momentum equation in the analysis of flow. We also understand how the momentum equation and principle of conservation of momentum is used to predict forces induced by flowing fluids. And then we apply Bernoulli and momentum equation to solve fluid mechanics problems. So next, we have the modification of Bernoulli's equation. So in practice, the total energy of a streamline does not remain constant. The energy is lost through the friction, and the external energy may be either added up by a pump or extracted by a turbine. So we can, paano natin malaman kung ang gagamitin natin is pump or turbine? Gagamitin natin ang pump if ever, halimbawa lang, dito yung ating river, nasa baba, di ba? And then yung community natin is nasa taas. Yung ating mga bahay-bahay nandito. So paano makaka-access na hindi maglalakad yung ating community para kumuha ng water dito sa ating sa baba? So magagamit sila ng device, mechanical device. So meron silang ilalagay na pipe, and then somewhere down there, meron tayong i-install na mechanical device such as pump para yun siya yung hihigop or kukuha ng ating water from the lower ground to the upper ground. So siya yung ayan yung ginagamit. So saan naman yung ating turbine? Yung turbine, magagamit ito sa mga dams. Example nito, from the higher ground yung ating water, and then yung pababa niya, di ba mababa yung ating water, syempre. So masyadong malakas yung energy ng ating water at that point. So mahirap siya ika-catch, di ba? So wala naman mag-catch ng water from that point na halos mahihigop ko ng tubig. So meron tayong mechanical device na magpapa-lower ng energy ng flowing ng water from that point. So from falls or dams, so we have turbine to reduce that energy na makakaya lang ng community kumuha doon sa or ma-reduce kumbaga lang ating energy from that flowing water. So minsan from that, yung turbine, ginagamit din yan siya para ma-convert yung energy ng water into electricity. Okay. So consider a streamline between 2 points, 1 and 2. So dali lang. Ay, wait, ano nangyari? So if the energy had lost through friction is denoted by H sub F, and the external energy had added, say by pump, so plus, and or extracted by the turbine, so negative, then yung ating Bernoulli's equation may be written as a positive negative H sub E, depende ito, positive if pump and negative if turbine is equals to H sub 2 plus or yung ating head sa section 2 plus yung ating and head loss due to friction or H sub F. So elaborate natin or P sub 1 over the density times gravity plus V sub 1 squared over 2G plus Z sub 1 or yung ating head sa section 1. Plus or minus yung ating energy added or extracted by the pump or turbine respectively is equals to the pressure sub 2 over weight density times gravity plus V sub 2 squared over 2G plus yung ating elevation head sa section 2 plus yung ating head loss due to friction. Again, yung ating H sub E is the energy head added or losses, a loss due to external sources such as pump or turbine. This equation is really a statement of the first law of thermodynamics for an incompressible fluid. So, doon nagtatapos yung ating recap regarding sa ating fundamentals of fluid flow. So before we proceed sa ating problem solving, meron lang tayong video presentation para mas maintindihan or mas ma-visualize ninyo yung ating mga formula. Okay, so we have here a video presentation. So let's play it and then makinig students.
Hi, hello everyone. Welcome back to De La Cruz Engineering videos. So in this video, we'll be discussing and solving problems involving the fluid flow and pipes in hydraulics. Okay, so let us call this one as part 1 because we'll be having series of discussions on fluid flow and different kind of problems involving Bernoulli's equation and any types of flows in a pipe. All right. So most commonly board exam type questions. This is intended for students that will.
Add water na? Ito!